Hello guys, welcome to my channel. Today we will discuss about reverse power trip in generator. What is reverse power relay? A reverse power relay is a protective transmitter that protects the turbine or motor from damage upon a reverse power condition. A generator can work as a synchronous compensator if the driving torque is less than the total loss in the system, taking necessary power from the network. For instance, reducing the steam flow in steam turbines can result in overheating since the cooling effect of the turbine blade is reduced. By supplying enough torque to keep the rotor spinning at the same frequency as the connecting bus, the generator will draw power from the bus bar rather than supplying power, causing a reverse power flow. It can also occur if the synchroscope is rotating slowly and then closing the breaker during synchronization. Instead of supplying current through the bus, the generator will be drawing current from the bus. This usually happens when the breaker is closed and the synchroscope is rotating fast in an anticlockwise direction. Why reverse power relay is important? When multiple power units are running in a parallel direction and a reverse power flow occurs, they may switch to drawing power from the main busbar. This can overload the power supply unit, causing a total power failure or a preferential trip. The faulty unit will continue drawing power from the main busbar, causing a motoring effect. In the worst case scenario, the RPM will shoot up, leading to overspeed trip or mechanical failure to the motor or turbine. A reverse power relay prevents all these problems from happening by preventing overheating and possible mechanical damage to the prime mover. It also prevents the turbine or motor from excessive overspeeding to maintain the regular cooling effect of the turbines. Reverse power relay construction and working. The relay is made of a lightweight non-magnetic aluminum disc between two soft laminated iron core electromagnets and fixed on a spindle running on low friction bearings. The upper electromagnet is wound with a voltage coil which is then supplied from one phase and an artificial neutral of the generator output. The other magnet has a current coil supplied from a current transformer connected to the same phase as the voltage in the upper electromagnet. The voltage coil has a high inductance designed in a way that the voltage lags the current in the coil by about 90 degrees. This lag ensures that the magnetic field generated from the current in the upper coil lags the magnetic field produced by the current in the lower electromagnet. The two magnetic fields which are out of phase produces eddy current in the aluminum disc, and this creates a torque that tries to rotate the disc. Under normal condition, when power is flowing as expected, the trip contacts of the relay are open and the disc is against a stop. If a reverse power starts to flow, the disc rotates in the opposite direction, moves away from the stop and towards the trip contacts that activates the trip circuit. Most of the reverse power relay have adjustable settings to allow the customer to do the setting according to the installed equipment. The trip point is usually adjusted to between 2 to 20% of the input current, while the time delay is adjusted from 0 to 20 seconds. A 5-second time delay is often used to avoid tripping the circuit during synchronization. In most practical applications, the reverse power setting are between 8 to 15% for diesel engine and between 2 to 6% for turbine power movers. Advantages of reverse power relay: prevents power from flowing in reverse direction and damaging the generator stator. Prevents damage to the prime mover. Prevents fire or explosions that may be caused by unburned fuel in the generator.